Hi all, once again welcome back to Chemist. So today we'll have the part 7 of the question paper discussion that we were so far discussing. For those who have not gone through the previous videos of regarding this question paper discussion, I have created a playlist in the channel. You can just go through for getting all the videos that I have previously posted. So without wasting much time, let's move on to the first question. So the first question of this video is about accuracy, which is a topic from data analysis or analytical chemistry. I think you might be familiar with the terms accuracy and precision. So these are the expression. These are the terms when you use for expressing the correctness of an experiment or how the experiment, the result obtained in an experiment deviates from the value that we expect and all. So before moving on to this question, we'll have a discussion regarding accuracy and precision because it's very important. We need to have this idea for working out the next question as well. So accuracy is actually the closeness with the true value of the quantity being measured. So suppose in your experiment, you are measuring some quantity like suppose you are having a box and you are asked to find out the length of the box, and actually the length of the box is 5 centimeter, but when you are measuring you are getting it as 4.9 centimeter, right? So that may be due to the problem that is associated with the instrument that you are used for measuring the length. For example, suppose you are using a scale that may be having some error in the measurement, the error associated with that instrument. So you are not getting 5, instead you are getting 4.9 centimeter. So we can say that there is a error of 0.1 centimeter, right? Suppose another person is measuring with some other experiment, or maybe the same person is measuring with the same instrument. Then he finds that the length is only 4.8. So then we can say that there is an error of 0.2 centimeter. So the actual value is actually 5, and suppose A is the first person, he is measuring it as 4.9, and B, he is measuring it as 4.8. Then when we compare A and B, A is more accurate because the value that A got is more closer towards the true value or the accepted value. But compared to A, the measurement of B is less accurate because it is having an error of 0.2. So this is how you express the accuracy. For expressing accuracy, you always need a reference value or a true value. But precision, on the other hand, is very much different from accuracy. In precision, you are measuring the reproducibility of the measurement. That is, you want to measure the length of a, consider the same example, length of a box. And you are using a single instrument, that is a single scale for measuring the length of the box. And you are each time when you measure the length of the box, you are noting it out in your notebook. Uh, Assume like that. So in the first measurement, you are getting a value of 4.9. In the second measurement, you are getting a value of 4.8. In the third measurement, again, you are getting a value of 4.9. So in the similar way, you can carry out n number of observations. Suppose you are carrying out 10 observation. If in 10 observation you will be having 10 value, and how each value is related to towards each other, that is how, whether they are close or whether you are having some deviation. So suppose in one measurement, if you are getting 4.5, there is a much deviation from the other values, that is 4.9, 4.8 and all. So in precision, we actually measure the degree of closeness between the observations, the different observation that we carry out. So it actually measures the reproducibility of the measurement. That is, whether we'll be able to reproduce the same experiment getting the same result. That is what is meant by precision. So there is a very much difference between accuracy and precision. In accuracy, you are having a true value and you are measuring how the measured value is close to the true value. But in the case of precision, you are not having any value called true value or accepted value. Instead, you are having different measured value and how these measured values are close to each other. That is what is meant by precision. Okay, so that is the basic difference between accuracy and precision. So this can be better understood by considering this graph. So here you can see that you are having a reference value and a experimentally observed value. And accuracy, it actually measures the difference between the two. But when you consider precision, precision actually it describes how the measured value deviates from the equilibrium value, or the not the true value. That is, you'll be having a correct value, and how the different observation, what can be the deviation from the original value, it can be towards left or towards right. So this is the diagram which can signify the difference between accuracy and precision. Now these are also some diagram which help us to understand accuracy and precision in detail. That is, when you consider this figure, you can see that all the points are on the focus. That means this is a highly accurate measurement, and moreover all the values are somewhat related, therefore this is also having high precision. But when you come to this diagram, you can see that this is the focus that you're having, or the true value, but neither values are on the focus. Therefore, not at all, even a single value is on the focus. So you can say that this is a low accuracy method, but all these measured values are related towards each other. That is, they are having high precision. Here you can see that all of them have uh, focused on the, that is, they fall into the focus. Therefore we can say that this is an highly accurate method, but all the values are on different side. That means this is having low precision. So here when you see, no, not at all a single point is also is on the focus, therefore this is a low accuracy method, and moreover all of them are distributed throughout the diagram, and they are not close towards each other, therefore this is having low precision. So this is how you distinguish between accuracy and precision. And you can go through these points of differences between accuracy and precision. I'm not going into the details of these ones, so let's move on to the so before that we have to answer this question. Accuracy expresses the, therefore this expresses the correctness of the experiment, because how close the value obtained is to the true value. That is what we measure in accuracy. Therefore it gives or expresses the correctness of an experiment, whereas reproducibility of an experiment is expressed by precision. Precision actually gives the reproducibility of an experiment, therefore this is the correct option. So let's have the next question. Again, the second question is also about something which is related with accuracy and precision. I think now you'll be able to understand in a better way. In an experiment, the values 2.2, 2.3 and 2.4 are obtained, while the true value is 4.6. Now, if we double each value, then we are asked to find out what happens to the precision and accuracy. So you're actually having a true value. Maybe it will be, it can be a length of a material, breadth of the material, and sometimes it can be a viscosity or refractive index, or whatever it is. So we don't need to understand what is a type of experiment that we are carrying on, but it is given that 4.6 is the true value. And you are having different individual measurement values as well, 2.2, 2.3, 2.4, etc. Now what happens if you double these values? What happens to accuracy and precision? Now accuracy, you know that accuracy is something which is related with the agreement between the measured value and the true value. Okay, so true value is actually 4.6. So if you are getting some value which is closer to what 4.6, we can say that it is a more accurate method, right? On the other hand, precision Precision is expressed in terms of degree of agreement between the different observations. So if you are having N1, N2, N3 observation, how close these are. Okay, so this is what we express in precision. So if it is closer, we can say that it is more precise. Now in this question, we are given that the true value is 4.6 and the individual values are 2.2, 2.3, 2.4, right? Now you're doubling, actually you're doubling the observation, different observation. You are doubling the observation. Then you're asked to find out what happens to precision and accuracy. Actually, when you consider this observation, that is 2.2, 2.3 and 2.4 and the true value, you know that accuracy, a method becomes more accurate when the observation is very much closer towards true value. So normally you can see that all the three observations, they show a very much deviation from the true value. That is because if you find the difference between 4.6 and 2.2, it comes around 2.4, and similarly 4.6 and 2.3, it comes around 2.3, and the difference between 4.6 and 2.4, it comes around 2.2. So there is a very much deviation when you consider all the observation. So this is actually a low accurate method, we can say. But suppose we are doubling. When you are doubling each value, you can see that this will become 4.4. This will become 4.9, and this will become 4. I'm sorry, you're not squaring this one, you are actually doubling. So you have to have the values like 2 into 2.2, 2 into 2.3, etc. So this will become 2 into 2.2 is 4.4. Here you will be having 4.6 as the value, and this is 4.8. Okay, when you compare these values with the true value, which is 4.6, we can say that they are closer towards each other or they are more accurate. So when you double the experiment, actually accuracy is increasing. Okay, accuracy is increasing. So you are having two options with this answer. That is, accuracy is increasing when you double different value. Now what happens to the precision? That is, the different experimental values are 2.2, 2.3, 2.4, etc. Now when you consider the difference between these two values, it is 0.1. Here also the value is 0.1. So the degree of agreement between the value comes around 0.1. Now if you are doubling, you are having the value 4.4, 4.6, 4.8. Now the difference that you are having here is 0.2. Here also you are having a difference of 0.2. So the degree of agreement between, so that we can say that the degree of agreement between the neighboring value, that is 2.2 and 2.3, initially it was all 0.1. Now it is all 0.2. So it doesn't change much. The difference between the neighboring value, it remains a constant even if you double each value. That means you can say that precision is not changing, right? There is no increase or decrease in precision. The difference is always remaining as a constant. Therefore, we can say that the precision remains the same, or it remains unchanged. Accuracy is increasing, but precision remains unchanged. Therefore, this is the correct option. Okay, so let's have the third question. Now let's have the third question, and this question is about differential terminal analysis, or DTA. DTA is a kind of thermal analysis. You are having different types of thermal analysis like TG, thermogravimetry, differential thermogravimetry like DTG, DTA is there, and DSC, differential scanning calorimetry. These are some kinds of thermal analysis that we perform with a specimen or a material. So that gives the decomposition behavior of the material. And in DTA, you will be having the sample as well as a reference material, and both the materials will be heated, and the difference in the temperature between the sample and the reference material is actually plotted as a function of temperature. Therefore, the correct option is delta T versus temperature. And the graph that you will obtain in a DT analysis is something like this. That is, you can have a peak pointing towards upside and downside, and in the upside that is termed as an exotherm, and the one which is pointing downward is termed as the endotherm. And this is a typical representation of a DTA graph. You can have different types of graph based on the material that you are analyzing. But the basic idea is that in DTA, you'll be having a sample as well as a reference material, and both of them are heated, and the difference in the temperature between the two is actually measured as a function of temperature. Therefore, the correct option is option B. So let's have the next question. So the last question of this video is about EDTA. It is a multidentate ligand, in particular a hexadentate ligand that we use in analytical chemistry, especially in the detection of some metals and all. I think you will be familiar with EDTA titrations that you carry out in your lab. So you are asked to find out the donor atoms of EDTA, and different options are given, and basically EDTA is nothing but it is ethylene diamine tetraacetic acid. That is, ethylene diamine means it is actually a derivative of ethylene, that is CH2 double bond CH2, and both the carbon atom, they are saturated with the amino group NH2. Initially it is NH2, that is ethylene diamine, and the hydrogen atoms of the amino group is then replaced by acetic acid or acetate group. So this is acetate, and these hydrogen atoms which are represented in red color, they are replaceable or they are acidic. So when you remove all these hydrogen atoms, it can lead to the formation of a 4- ligand. So it is acting as a hexadentate ligand because it can coordinate with this nitrogen atom. In the green color, you can see the lone pairs on this nitrogen atom. So this lone pair can be donated so that these two nitrogen atom can act as donor atom. Similarly, these hydrogen atom represented in red color, they can be replaced and it will become the corresponding carboxylate anion, that is C double bond O minus ion. It can form, all the 4 acetic acid group can form acetate ion. Therefore, these oxygen atoms, these 4 different oxygen atoms, they can also coordinate with the metal. So this is how it coordinates with the metal. That is, this is the same hexadentate EDTA ligand that we have represented in this form. That is, these two are the CH2 group, and this is CH2 C double bond O minus. So this is how it coordinates with the metal. So you can see that it is coordinated through 2 nitrogen atom and 4 oxygen atom, and it forms an octahedral complex. The geometry is octahedral. Therefore, the correct option for this question is 4 nitrogen atoms, sorry, 2 nitrogen atoms and 4 oxygen atoms. Option B is the right answer. Okay. So that's all for this video. If you like the video, please do like, subscribe and share, and I'll be coming soon with the next part of the question paper discussion. So till then, take care and bye-bye.